Welcome back, students. Today we are going to see the exercise 1 of the chapter differentiation. In this we have the first question, find dy upon dx. So in this first we have given x is equal to ad square, y is equal to twice ad. Now in this type of questions, first given two equations that x is equal to ad square and y is equal to twice ad, we have to differentiate them but with respect to t. In previous examples, every time we differentiate the equations with respect to x, but here in the case a is a constant, t is variable, a is constant, t is variable. So these two equations, first we are going to differentiate with respect to t. So we write here differentiate x and y with respect to t here. So see what happened. Dx upon dt, it is equal to d by dt of at square, and here dy upon dt, it is equal to d by dt of twice at. So in this way we differentiate both the equations here with respect to t. Now after this, dx upon dt, it is equal to, this a is a constant, so we write it as it is, and derivative of t square with respect to t, so that is twice t. Twice t. Now here also dy upon dt is equal to that twice a is a constant here, and derivative of t with respect to t, that is 1. So finally we have this equation 1 and this equation 2. Now look here, we have to find dy upon dx, and we have dx upon dt, dy upon dt. So as we divide this equation 2 by equation 1, so what we are doing, divide equation 1 and 2. So what happened? Dy upon dt total divided by dx upon dt, and that is equal to twice a upon this a into twice t here, so we write 2at. Now we cancel this 2 here, cancel this a also, so we remain with 1 upon t. So this part we can write dy upon dt, and this inverse in multiplication, that is dt upon dx. This is equal to 1 upon t. So we cancel dt, dt. So finally we remain with dy upon dx. Therefore, dy upon dx, it is equal to 1 upon t. So in this way we finally prove this, or we get the value of dy upon dx, that is 1 upon t. Now look at the second question. It have same pattern like previous one. So what question we have given? We have to find dy upon dx, and we have given x it is equal to a cot theta and y it is equal to b cosec theta. So here also we have to find the value of dy upon dx. So very first we are going to differentiate x and y with respect to theta, because theta is a variable here. So derivative of x here, dx upon d theta, it is equal to a into d by d theta into cot theta. Now a as it is, in bracket minus derivative of cot theta, it is minus cosec square theta. So what we get final? Minus a cosec square theta equation 1. So in this way we get the first part here, first equation. Now differentiate y with respect to x. So dy upon d theta it is equal to, d is a constant and d by d theta into cosec theta, that is equal to b in bracket minus derivative of cosec theta minus cosec theta into cot theta, and that is equal to this minus first and then b into cosec theta into cot theta equation number 2. Now see, we have to find dy upon dx, so we should divide this equation 2 by equation 1. So divide equation 2 by 1. So dy upon d theta, we write in the multiplication by taking the inverse of this part, that is d theta upon dx. See, we divide this term by this term, but we write in the form of multiplication. First term I write as it is here, and second term its inverse is taken here. So that is equal to, so this part first, minus b cosec theta into cot theta divided by minus a cosec square theta. So finally this cosec cancel with the square, minus minus become plus, so b upon a, and here we remain with 1 upon cosec theta into cot theta. Now b upon a into inverse of cosec is sine here, into the cot can be written as cos theta upon sine theta. So finally we cancel sine theta with sine theta, and here also we cancel d theta d theta. So finally we remain with dy upon dx. It is equal to b upon a into cos theta. So this is our final answer. Dy upon dx, it is equal to b upon a into cos theta. Look at the question number 3. In this also we have to find dy upon dx, and we have given here x it is equal to square root of a square plus m square, y it is equal to log of a square plus m square. So very first we are going to differentiate both the equations with respect to m here. So differentiate x comma y with respect to m. So dx upon dm it is equal to d by dm of square root of a square plus m square. So take the derivative of this part here, 1 upon 2 square root of a square plus m square, you know derivative of square root, into d by dx of a square plus m square. After this, derivative of a square is 0 and m square is 2m. Derivative of a square is 0 and m square is twice m. So twice m divided by 2 square root of a square plus m square. So finally what we cancel here? 2 cancel with 2. So we have m upon square root of a square plus m square equation 1. So in this way we differentiate x with respect to m. Now similarly we have to differentiate y respect to m. So we have dy upon dm, it is equal to d by dx of log of a square plus m square. Now all you know the derivative of log, that is 1 log x 1 upon x. So similarly we have 1 upon a square plus m square. This is the derivative of log here. Now into d by dx of a square plus m square. Now the derivative of a square is 0 and m square is 2m. So we have 2m upon a square plus m square, equation number 2 here. So also we get the dy upon dm. So finally we have to find the value of dy upon dx. So we should divide this equation 2 by equation 1. So divide equation 2 by equation 1. So see this part first in the numerator, dy upon dx. The part which is dm. The part which is in the denominator, that we take inverse in the product. So dm upon dx, that is equal to this part here first, twice m upon a square plus m square. In product we take this inverse of this part there. So square root of a square plus m square divided by m. Now finally we cancel this m with this m, and final answer that dm cancel with dm. So dy upon dx, it is equal to this 2 here, square root of a square plus m square and divided by a square plus m square. Now see, this we again can simplify here. So 2 square root of a square plus m square divided by, now this part can be written like this, square root of a square plus m square into square root of a square plus m square. Right? This product of these two square root is a square plus m square. So this part can be written like this, and this square root cancel with this square root. So finally we have dy upon dx, it is equal to 2 upon square root of a square plus m square, and hence this is proved here. So it's very easy. What we does here, see, this part can be written product of two square root. So square root product become a square plus m square. So this square root with is cancelled with this, and finally we have 2 upon square root of a square plus m square is